Assalamualaikum and good day, Doctor. My name is Asha Adiba binti Muhammad Astro Armujoyo, and today I will talk about the atmospheric dispersion modeling. So, what is atmospheric dispersion modeling? It is the historical reliance on the atmosphere's self-cleaning properties for pollutant disposal. It has the ability to disperse the gaseous pollutants depends on the meteorological condition, and the factors of the atmospheric dispersion include wind speed, the direction, and the atmospheric stability. Why dispersion modeling is important? Because it is impossible to measure impacts from future facilities. The modeling is cost-effective compared to the extensive measurement programs. It is practical for isolating the effects of specific causes, and it provides a reproducible tool even though it may not be 100% accurate. Next, we go to the physical explanation of atmospheric dispersion modeling. For the spreading of a bend-over plump, a continuous stream of pollutant will release into a steady wind in open atmosphere will rise. The bend-over and travel with the main wind, which diluted the pollutants and carry them away from the sources. The plump will spread out or disperse both in horizontal and vertical direction from the center line. A matter will move from a region of high concentration to a lower concentration. Next, the instantaneous plump and a 1-hour average plump. The eddies and wind fluctuations causes the plump to be on a time average rather than instantaneous basis. The time average pollutant concentration at distance x, meanwhile the downwind from source distributed is at y direction. As the distance x increases, the pollutant spreads further in the y direction and z direction, and the maximum concentration will decrease. Next, for the downwind behavior, the elevated transverse concentration. The figure shows the plump high concentration profiles in y direction. Similar spreading of the plump occurs in a vertical concentration and resulting in another normal distribution of pollutant concentration. The distribution of pollutant is called as binormal. This is the equation used for Gaussian model for a dispersion of a non-reactive gases pollutant from an elevated sources. And if the pollutant dispersing infinitely in the z direction including underground, equation 20.2a will be used. At the atmospheric stability classes, it shows a plotted graph developed by application of theoretical principles to the analysis of an actual dispersion data. And on the atmospheric stability classes, these tables will be used to calculate the wind speed at stack height. Next, for the averaging times between 10 minutes and 5 hours, we were suggested to use the equation on the dependence of concentration on averaging time. Meanwhile, in estimating the maximum downwind ground level concentration, the equation 20.6 will be used, where it fit to a polynomial equation by Ranges 1976. This figure represents the Turner results as a plot of x maximum versus the equation. The solid line will represent the various stability classes, while the number along the lines represent the values of the effective stack height. For tall stacks and plumb rise with everything else constant, the concentration at any point x should go very down quickly as h increases. And on the figure left shows the design procedures for the stack height. For equation 20.12 and 20.13, it will be used in calculating the tall stack and plumb rise under a neutral condition. For critical wind speed determination, it depends on the stability and the specific plumb rise model used. And next, for other stack design considerations, the air blows past a structure and forms a lower region behind the structure. It recirculating the eddies and wake a formation. The rule of thumb for stack designers is to make the stack height at least at 2.5 times the height of the highest building near the stack. A computer program dispersion modeling is an attempt to represent by mathematical or statistical means to observe phenomena of the pollutants being diluted and dispersed in the open atmosphere. Although many different models have been tried, with varying degrees of success, the most widely used today are the Gaussian-based models, and it only used to solve the problems for which it was designed. The modeling sources and line source models. The figure shows the y-axis is collinear with the FLLS, which is perpendicular to the wind, while the x-axis is parallel with the wind and passes through the receptor. Since the sigma y and sigma z are constant with respect to y1, the equation 20.25 can be integrated over the FLLS and written as the equation 20.26 and 20.27. And to conclude this topic, the air pollution occurs when too much waste material is emitted into the thin air. Atmospheric dispersion modeling will help in transporting and diluting the eddies. That's all from me. Thank you.